In this learning module, we will consider the ways in which Spotfire parallel coordinate plots may be used to visualize data, including their utility in evaluating multivariate data, which occupies vastly different data ranges. We will consider the normalization which is applied in order to make this possible, because the dynamic nature of these calculations plays a big role in the interpretation of the patterns you see displayed in the parallel coordinate plot. Note that you could consider representing your multivariate data in the form of a line chart, where increasing values for each dimension are represented along the y-axis of the line chart, and the items described represent individual lines or patterns. In this example, the composition of different food items. As you can see, soybeans are high in protein and mustard seeds are high in fat. However, take a look at the comparison of fiber quantities between these different food items. The range of values is much narrower. So, what happens when the items you are comparing are represented by measures on extremely different scales? For example, let's say that we're in the market to buy a new car. If we were to compare 3 other cars, labeled Car A, Car B, and Car C, to our current car in a line chart of the values for price, mileage, passenger space, cargo space, and engine power, the numerical range of the price values would overshadow all other numbers, making it impossible to reasonably compare all dimensions of the data. Instead of a line chart, if we insert a parallel coordinate plot, the data is normalized to scale between 0 and 100% based upon the minimum and maximum value for each measure, making an equally weighted comparison of each measure possible. Now we can select our new car based upon the desired magnitude of values along the range of each of the metrics we have available. If we are focused on fuel efficiency and low price, Car C may be the one for us. However, we may have to sacrifice space and engine power in that choice. Now, let's take a look at a demonstration which highlights the features of several parallel coordinate plot visualization examples. Use Open File to navigate to the example with Interpreting Parallel Coordinate Plots in the title. Click Open and agree to the terms and conditions of use. The data table, which supports the parallel coordinate plots presented on the next 2 pages, contains purchase amounts made in different departments collected from a group of 754 loyalty program customers across our chain of 84 Megamark stores. On the next page, this parallel coordinate plot has been configured to display each customer's purchase pattern across the 7 departments as an individual line. You will notice that the y-axis scale reads 0 to 100%. Therefore, each of these points with values of 100% represent the highest purchase amount in that department. As we hover our mouse over a line, it will be outlined or highlighted and reveal the relative purchase amounts that the customer made in other departments. For example, this male customer made relatively high purchase amounts in furniture, grocery, and clothing departments, relatively low purchases in toys and garden departments, and just on the low side of mid-range in electronics department purchases. If we wanted details for the big spenders in these first 5 departments, we could drag a rectangle to mark those patterns. Note that crossing any portion of a line with this marking area will mark the entire pattern within a parallel coordinate plot visualization. And we can now evaluate the data displayed in the Details on Demand panel. While the y-axis displays the normalized values of 0 to 100%, the actual values in each departmental column for the marked customers supplied by the underlying data table are displayed in the Details on Demand table. If we wanted to see the scale for these values displayed on the parallel coordinate plot, we could click on the department column label of interest, like shoes, and the range of values for that column will be displayed along the right side of the plot. While the shoe purchase amounts for all 754 customers range on the scale of roughly 0 to 300, clicking on the furniture label on this axis reveals the scale for that department, which ranges roughly between 0 and 2200. As with other visualization types, these scales will adjust with filtering. For example, if we remove Los Angeles customers from the visualizations, the furniture scale changes because some of the largest furniture purchase amounts were filtered away. Note that the y-axis scale still reads 0 to 100%, indicating that the normalization calculations are dynamic and will adjust when maximum or minimum values are filtered out from the plot. So if we filter out customers in urban store settings, the patterns adjust to the new maximum and minimum values in each column. This is a key element for understanding and interpreting parallel coordinate plots. The patterns displayed by each line represent the values relative to the other lines available in the plot. We could illustrate this relative comparison in an extreme situation by filtering to show only 2 customers. In this case, one customer must have the maximum purchase amount in each column, and the other must have the minimum purchase amount in each column. If we reset all filters, you may find that due to the dynamic nature of the normalization calculation, trellising parallel coordinate plots, for example, dragging and dropping store location on the final trellis target, is a better method for isolating patterns of interest due to the fact that the lines are not removed from the plot, and therefore the patterns remain the same, even though the lines appear in separate panels. If we click where there's nothing in order to unmark data and move on to the next page, you can see that categorical values have been applied to the trellis properties of these 2 parallel coordinate plots. The plot on the left has patterns separated into panels based upon assignment to store location and store setting values, while the plot on the right displays a panel for each of the 84 stores. Within each of those 84 panels are individual lines for each customer's purchase pattern across departments. Note, though, that in the plot on the left, each department column label is preceded by an aggregation. The legend reveals that these lines are not configured to display a line for each customer, or row in the underlying data table. Instead, the line by property has been assigned based upon store number. Therefore, there are 84 lines in this parallel coordinate plot, each representing the relative total purchase amounts made in each department in that store. So we can see that this rural New York store, store number 24 according to the tooltip information box, has some of the highest shoe and toy purchase totals. And marking that store will mark the lines for the individual customers who contributed to this summary pattern. Even higher toy purchase totals can be seen in this urban New York store, store number 32. And marking that pattern allows the customer patterns which contribute to that store's relatively high toy purchase totals to stand out.